It's good to be back in Vienna after so many years. So many things have changed. First of all, I'm not there in person, so thanks to the organizers for accommodating my remote telepresence. So last time I was in Vienna, it was a very special time for me because I believe it was the very first time that I introduced Next.js in public. And the world has changed a lot since then. So Next.js has grown quite a bit. Vercel is now the name of our company for which I'm the CEO. It used to be called Zeit. I guess I got into a little bit of a trademark infringement situation with Die Zeit in Germany, and I suppose Austria as well. And the world has changed a lot, I think, as well, because the type of software that we're developing these days and the types of software that we're going to be developing in the coming years has changed dramatically. And I'm going to be calling that the AI native user experiences of the internet. And I think one of the awesome opportunities about speaking to this crowd is that I think you all, this generation of developers, and specifically a lot of the people in this room, I think can be at the forefront of these revolutions happening with AI applications. And obviously, I think there's a ton of us that, even in our day to day, our experience as end users has been dramatically impacted by the rise of AI. Anytime I sit down and I open NeoVim, I turn on my language server for Copilot, and it auto-completes magically every thought that I have. It makes me a lot more productive, especially when I'm exploring new APIs and technologies that I haven't used yet. So for both developers and end users, we've seen dramatic change in the ways that we interact with computers. And this doesn't extend to just developer tools, but even the ability of creating search engines and new kinds of applications like ChatGPT. The impact is not just to developers for which AI makes a difference in productivity, but I also believe it extends to every single developer on earth that will be creating the software applications of the future. One mental model that I use a lot is this idea of software 1.0 versus software 2.0. Software 1.0 was sort of the Alan Turing software of we sit down and we come up with an application, we write down the code, we think about data structures, we think about programming languages. But the world is changing, and I like an article by Andrew Karpathy a lot in which he described software 2.0, which is a software that is significantly different in the way that it's constructed. We start creating software 2.0 applications primarily from large data sets to which we apply fairly simple algorithms, and then we scale compute. And with that, we end up with a program that we don't really fully understand. We know that there's all these weights, we know that there's this neural network, and we understand its behavior more probabilistically. Whereas in the world of software 1.0, we understand it very much deterministically. The case that I'll make today is that we're combining these two strands of DNA of software to bring these new software applications into the future. One way that you can imagine this transition is we used to discuss a lot that we would use machine learning to fuel applications. In the last wave of sort of artificial intelligence hype here in Silicon Valley, we would talk about machine learning, deep learning. Nowadays, it might seem like a simple distinction, but we talk a lot more about AI. So I want to make this case for the transition from ML to AI. First of all, I think the one that will be most interesting to this audience is you couldn't even get started using machine learning without knowing Python. The sort of barrier to entry was significant because a lot of this scientific compute required libraries like NumPy and a whole ecosystem of tools to train models. As we start going into this new AI revolution, you might have noticed that a lot of the APIs we use is, well, just making a fetch API call over the network to some OpenAI model. So I'm going to make the case that it's TypeScript that is at the forefront of this revolution. The way that we looked at machine learning was very much backend first. Sort of you sit down and start thinking about your data set, your data pipelines, your data hygiene, setting up like Spark jobs, Ray jobs, clusters, doing batch training runs, and so on. Whereas I'm going to make the case that when you're sitting down to create an application that uses AI today, you might just start with React. The deployment is actually pretty tedious. And of course, I'm biased because at Vercel, we make it really easy to deploy TypeScript applications. But I think the main distinction here, as I mentioned, is that when you would do machine learning in the past, and of course, behind, just like behind serverless, there are servers, behind models as a service, there's models that people train with Python. But the barrier to entry was significant because you had to sort of conceive an entire what we would call MLOps or machine learning operations pipeline, a lot of DIY, and the output of a lot of these applications would actually be a notebook instead of an application. So the fact that we can now sort of invoke a model over the network is changing software because we used to call databases over the network, and now we can sort of add these reasoning engines over the network. The other thing that's changing significantly is that when I use an AI model today, I used to think of training as the primary way that I could tune its behavior. And machine learning models that companies, especially startups, would train were relatively small. With the advent of large foundation models, what's happening is that I can just reuse a lot of the sort of public foundation of the new internet, very much like cloud. When I sit down and I use the cloud, I'm leveraging this massive amounts of investment, and I don't have to reinvent the wheels. I don't have to build my own data center. A similar thing is happening with large foundation models because I can sort of grab them off the shelf and I can prompt engineer them in order to sort of steer them in the direction that my application needs it. And this kind of takes us to our next point, which is the previous paradigm was very much training first, whereas now I can just reuse all this public infrastructure of models, prompt them very easily, and perhaps I do sort of the fine tuning and training later, or even create my own foundation model if I have a couple $100 million sitting around. And I think the big opportunity that I want to make the case for today is that, and why AI is so exciting, is that we're going to be shipping products instead of shipping research papers. And of course, this is an oversimplification of the ML world, but anytime you sit down today to sort of leverage this new LLM infrastructure, you're probably thinking more closely about the end user experience instead of about the model infrastructure itself. You can move really fast and sort of ship applications in days and weeks instead of quarters. And what's most exciting to me personally as an individual that likes to create and invest in developer tools, whether it's Next.js or Effect, the total addressable market of this new AI first revolution is ginormous if you're looking at the TypeScript world. Whereas if you're looking at sort of the numerical computing world, you're sort of like narrowing down the access to this technology to a lot fewer people. So the case I really want to make is that when I think about AI engineering in the future, I'm thinking about a TypeScript first experience and TypeScript engineer, which is really exciting. There's three generations of AI first or chatbot applications that we've seen sort of come into the scene. And what's amazing and exciting and sometimes frightening is just how fast we're disrupting ourselves and going through these generations of applications. So the first generation of chat model really happens a year ago, and it's kind of laughable to think about how fast this is all moving, right? But we have ChatGPT, and the first experience a lot of us had was you start using it and you're blown away. You're blown away because it knows how to code, it knows about history, it can write a poem. But then you sort of very quickly hit a de-optimization cliff. So, you basically hit an error case, right? Like you ask it, what's the temperature? You ask it something about the real world, and the reaction that you get is, as a large language model, I don't have information about the weather. Or you get things like my cutoff date was 2021 or 2022, sort of the legacy of the training time, so to speak. As we're getting more intelligent ourselves about how we leverage these models, we realize that the model itself is more of a reasoning engine rather than a repository of data. When I use a metaphor of software 1.0 and software 2.0, one thing that's maybe clever to point out is that in software 1.0, think LAMP stack. You have Linux, Apache, MySQL, PHP. That's the software 1.0 stack for a lot of us in the old days. As we go to software 2.0, there's sort of some analogs, right? So you have your database, and now you can say, well, instead of querying my database, I'm querying my model. But a very important distinction is that the database, again, is deterministic, it's correct, it's precise, whereas the model hallucinates, doesn't know certain things. It's a compression of the data in the training process. So what we realize is that if we make the model use tools, and this is going to be an important part of the presentation, we can sort of use it as a reasoning engine instead of as a thing that knows precisely information about the world. So chat experiences today can actually answer this question about what's the temperature in SF because they can invoke a tool to get the weather. So there's a new interface that has emerged between the software 1.0 application code that you're writing and the LLM or the software 2.0 infrastructure, which is the tools. And I think we're at the forefront of a third generation, which is why I made the case that the AI sort of application landscape is going to be front and first. And a lot of us will be building these applications, is that we can sort of embed UI into these AI apps. Instead of just responding with text, or you might have seen a stream of Markdown come from ChatGPT, we can create truly awesome interactive applications. And this is where I think the entire world of AI application development is headed. And I'll talk about a little bit about how we can implement it. I'll walk you through some examples that I admit are pretty funny because some of you might have noticed in the news that I believe it's Canada Airlines that had a hiccup with their AI. But I'll make a case of what are some of the opportunities that exist if you're not ChatGPT. If you're creating a new startup, if you're working for a company and you sort of want to embed an AI experience based on the expectations that the new consumer will have. The new consumer of 2024 and forwards will know about ChatGPT. They will know how to interact over voice, over natural language, with voice assistants like Alexa or Siri, and so on. So we have this hypothetical AI Airways, awesome airline. I would totally fly them anytime. And I come to this website and I want to make a change for my flight to tomorrow. So if I'm on the go, I probably don't have time to figure out an entire new UI. And as we all know, a lot of these airlines UIs are pretty complicated. So I'll just go directly to the chat experience. I'll say, I'd like to change my flight to tomorrow. The ideal experience here is that the bot will have memory, will have context, will have access to data, and it'll sort of present me with options about what flight I want to modify. It can then present me with a simple interface to select what are my options to change my flight. Notice that in a generation 1 or generation 2 application, all your AI application could do is just like give you text. If we start embedding UI into these applications, we can kind of get the best of both worlds because this is a much richer representation of the information that I'm interested in. For example, if it's business class, if it's economy, etc. And a particular example here would be that when I want to make the change, I would actually interact and tap on this rather than write it down. So the bot will have now the context. It will ask for my confirmation, at which point I can also reply in natural language. I can have more interactive UI. For example, if I want to modify the seat. Something that's extremely compelling about this type of interactions, and you probably have seen this with ChatGPT and DALL-E, is that I can switch between modes very dynamically. I can go from doing a translation task to some image generation task to a voice task. And this would be an example of saying, well, there's an opportunity here to discover a new preference that would otherwise taken me a long time to find where in this very complex application the seat changing UI lives. And then obviously the user would go on to confirm their booking. What's really cool about this chatbot sort of experiences as well is just how much more context the user can be presented with. If you think about not having an airline online, but if you think about even your own applications, your own SaaS applications, typical things that the user might be struggling with, like updating credit cards information when a payment failed or changing their password, are things where, again, we would dynamically generate and render UI according to the user preference. something that's very hard to do with GUI products today is understanding why the user is motivated to do certain things. So you could imagine an AI actually having an opportunity to ask discretionary information that would inform the product creator about whether they're changing their password because they're scared of a potential hack or breach, or just overall get more data into the system. This is something that AI applications by default do that perhaps we don't always have the discipline to do with typical SaaS products, which I'm really excited about. It's this flywheel of getting data constantly into the system. If you think about VS Code and Copilot, it's constantly getting data about the acceptance rate of the suggestions that it's presenting to you. So a very rich data flywheel is one of the reasons that I believe that these are the kinds of products that are going to succeed in the future and possibly outcompete the more traditional ones. So in this case, I reply, okay, it's account security that motivated me to change the password. React, I believe, is incredibly well placed, and this is probably the most exciting kind of like right time at right place situation for us front end engineers. Because React sort of set out to create a model for componentizing the world. Every UI widget that you had on a page could now become a discrete component that was composable with the rest of your application. It's a solid sort of abstraction to bank on and invest in early in your application development journey because you can sort of reuse them, compose them, etc. And React sort of started on the client side. So if you think about the origins of React, the things that Meta was componentifying were perhaps the notification badge for the chat state on the navigation of Facebook, then the chat widget, sort of started kind of growing from the leaf into the root of the application. Now, the problem that sort of emerged is that as your application becomes very dynamic on the client side, you kind of started creating this massive bundles of code. Having been in the React community for so long, we have gotten our fair amount of heat from folks pointing out that there's a lot of JS being shipped to clients. In fact, this morning, I was looking at another Hacker News post about like, hey, all these applications are so many megabytes of code. So something that's really exciting, though, is that we've learned that the right place for React is actually the server side. And one of the big reasons for that, and by the way, that's a controversial statement, but one of the reasons for that is more generally that React rendering has to be co-located with the data source. So I think you could be using React client side with a local data store and a local first architecture, or you could be using React in the cloud close to your PostgreSQL database. But one thing that's clear is that when you do have lots of data in the cloud, putting the code for rendering the output of that data as close as possible to the database creates an enormous latency benefit. And what's really interesting in the context of AI applications is that we know that the LLMs, the vector databases, a lot of the information lookup systems that I actually just described, like the API call that you make to the Flight API service, or the API call that you make to the microservice for changing your password or getting your account status, a lot of that does live in the cloud. So the fact that React was already investing in streaming server-side rendering before AI even was a thing, just for the sake of creating really fast applications, really fast e-commerce experiences, really fast storefronts, happens to be very timely. Because one of the challenges with lots of client-side code in React was consider an application that is made up for thousands or tens of thousands of components. Consider the modern product engineering lifecycle that involves running a lot of experiments. Consider actually the European market, which we work with a lot, where you might have to render a set of products for a certain country, and you have to adapt the currency dynamically. You have to update the language dynamically. Maybe someone tailors their language more precisely for Austria than Germany, and so on and so forth. So React was doing the sort of working on the infrastructure to actually answer the needs of those, let's call them like pure software 1.0 applications. And this also extended to introducing new innovative APIs like server actions. So we kind of set up the right foundations for exchanging data from client to server and server to client in the most efficient way possible. And of course, I'm biased, but Next.js sort of bundles all of this technology up so that it's really, really easy for you to use. And I think this streaming server-side rendering technology in combination with LLMs would sort of be a big part of the future. Now let's talk about sort of how we could go about implementing one of those novel applications where the LLM is streaming UIs based on the information exchange with the client. To answer this task, we created a package called AI, very appropriately named, that you can just find on NPM. And the very, very simple architecture is you have application code running on sort of the server side. And by that, I mean the sort of React server component side. If you're a little confused about the terminology, I suggest you look at the Dan Avramov Twitter stream where he's trying to explain what this all means. But fundamentally, you have a set of components, not all of which, and this is sort of the key insight, not all of which are needed by the client at all times. I mentioned earlier that there's this sort of tools thing that we can now use in LLMs, which is what makes the LLM be able to query an external oracle. Like I mentioned earlier, the thing that allowed us to transition from, I'm an LLM and I don't know what the weather is, to, oh, I can actually go and retrieve the weather. And so we can have the application code interact with the LLM, negotiate inputs and outputs in a normalized structure world, and then return it back. So going back to sort of that experience earlier, where I would say, I'm a user and I say, hey, status of flight so-and-so, the way that we encode this is we create a message that we send up to the LLM that says, first of all, what is the prompt by the user? Typically, we would annotate this by saying specifically, this is from the user as opposed to from the operator. And then we specify a schema of the function calls that this LLM can make. And by the way, the function call conception here is actually very much in the sense of like declarative effects, as opposed to thinking of and this confused me in the beginning. So I was assuming that when people called the OpenAI API function calling, that it was actually producing the side effect. What is really cool about this is that it's actually declaring the side effect. So in this case, the AI sort of internally says, what I would do is I would call get flight info, which is the function that we're providing, and I extracted that the flight number matches what's in the user input. This is amazing because if you think about that ML versus AI world that I was talking about, in the ML world, this was really hard to do, to train a model to extract the flight code and training on all your features and sanitize the data and run your evals and benchmarks. Now we just get it for free by writing English and a little bit of JSON. It's actually a pretty awesome world. And then the sort of unique thing that we're adding into this world with the AI SDK is the ability to now map that function called that structured data into a JSX stream that leverages that React Server Component server-side streaming technology I was talking about. This can get actually pretty complex. So the tools that you offer up the AI can be very, very different. So typically in a real-world application, you would offer a lot of them. I shall mention that AI applications are getting pretty complex. There is routing layers that we use where we look at a certain query with a certain model. Then maybe we decide that with a certain tool, we route it to a smaller model, a simpler model, and so on. So running a little bit short on time, but I'll sort of speed date through this. We sort of keep that internal log of conversation with the AI such that we can refer to it later. And again, I can now bring another component that crucially, the user hasn't even seen yet. So the typical client-side heavy world of React required a sort of you pre-download lots and lots of component variations. Whereas in this case, the server, which is like a big boy, can actually load lots of components. Like we have more memory, we have more compute. The client, we assume, is like less, basically like less powerful. So we sort of do a projection of a subset of the server world onto the client. So, and don't get too upset about the usage of Zod here. We'll get into that later. The fundamental idea here is actually pretty simple: is that you have an asynchronous function, you define your tools, you declare your schema, and then you get a render function, and then that neatly sort of integrates into RSC. So just walk through the different parts of the code here. Very crucially, this these components can be interactive on the client as well, so that they have state and they can be rich on the client side. Now, when I was thinking about this talk, I realized the AI world is actually a very complex and complicated world, and it has significant challenges and shortcomings. Even as I was creating that example of the AI airlines, news broke out of some airline that suffered from giving the user false data and actually having problems in production to the point where it had to get withdrawn. But I still believe that AI applications are the future. So, how do we sort of bring everybody along for the journey? How do we minimize error? How do we minimize latency, etc.? So, I'll enumerate a few of the challenges that I think have created a ton of opportunity for the developers in this room and many others throughout the world. Number one, in the creation of our own AI products, we've noticed that reliability is very challenging. I would even go as far as saying that reliability is the number one issue that we hear about AI developers facing today. And I'm kind of throwing OpenAI under the bus here, but I'll give them credit for being the absolute leader in the space. And the demand for their infrastructure has grown so exponentially, it's been hard to sort of offer a very, very consistent quality of service. I know they'll get there, but this is one of the issues. Alignment is another issue, and safety, because again, this sort of AIs will have new opportunities for ways in which they can be misused that we don't fully understand yet. For example, prompt injection attacks. Hallucination, as I called that earlier, is tricky. You can sort of talk a bot into saying things that it's not supposed to say, although I really believe that tools and constraints and evaluation frameworks and tests can vastly mitigate this problem. It is a risk that you have to constantly be thinking about. And the one that's actually really interesting that perhaps a lot of folks are not ultra familiar with is, and I kind of alluded to it earlier, the modern AI application stack is getting very, very, very complex. For example, one might assume that every production AI app is backed by one model. In reality, in prod, we use multiple models. For example, for V0, we use several models to process each and every query that people send into our product. We also have a lot of asynchrony, right? So I called out that the LLM doesn't have data about the flight, so it has to call out to an external system. Once again, an opportunity for a lot of things to go wrong. So this is where I think the strengths of, first of all, broadly the TypeScript ecosystem, but also the effect ecosystem are going to shine. Because if you think about reliability, well, retrying and observability are sort of the key components there to bring solutions to that problem. A lot can go wrong in these complex pipelines, and having very accurate error handling and retrying and the right algorithms for backoff is absolutely essential. In fact, during one of our launches, we learned this firsthand. Queuing and concurrency and quality of service is really complex. So you might want to prioritize, and you've probably seen this with a lot of AI products, that you have to give a higher quality of service to the users that are willing to pay more. And perhaps your differentiation between your free tier and your paid plan is actually that you give more priority to paying users. And you have to implement queues because there's a shortage of GPUs and there's fixed capacity. So I'm really excited about the opportunities for the effect ecosystem to sort of start contributing here. And I apologize for the typo here. The number one thing we can do is actually add effect schema support to the Vercel SDK so that we can sort of make the schemas pluggable. We're thinking about adding Valleybot, Zod, and others support into the system. The other thing to bring sort of education to a lot of the developers is examples that actually show off this real world complexity. And last but not least, the thing that I'm personally really excited about, and this is from learning some of the issues that we've had in production, is bringing deep automatic observability into these systems. We kind of talked about like, yes, there's problems with safety. Yes, there's problems that some users might steer the model in the wrong direction. But the cure here is to lean heavily into observability. There's an emergent category of tools that are sort of trying to become the testing and observability framework for software 2.0. Just like in software 1.0, we had like Datadog and Jest. We sort of now have to create the analog technologies to sort of tame the challenges that these new kinds of applications represent. If you're curious about this world and you want to get started, we've open source a bunch of templates. You can go to vercel.com/templates/AI. You can sort of our number one template today, maybe across the entire platform, is our chatbot. It's a good place to sort of start thinking about integrations. And I also encourage you to try out V0, which is our flagship AI product. For a lot of you that are maybe not so proficient in Tailwind or Shadcn UI, we've created this application to convert text prompts into working production code that you can use to create the apps of the future. Thank you so much for inviting me to give this presentation. I look forward to hearing all your comments, feedback, and contributions. Thank you all.